Welcome, everyone. I'm going to bring up my presentation. Forget test-driven development, focus on first instead. I realize it's probably a rather provocative title. I want to assure all who are present that this isn't some sort of anti-TDD screed. Yeah, this won't be an anti-TDD screed. I'm a huge fan, advocate, a longtime user of TDD. I got my start in development actually in extreme programming with all the agile engineering disciplines. And working with a whole lot of teams, coaching teams, going through many agile transformations in many organizations, I see that there is often a priority on TDD that comes from upper management. And I still, even through all of the training and the prioritization, it's rare to actually see teams embrace TDD. That sometimes that is because it's not well appreciated how difficult the mental mind shift is for the teams to actually do true TDD. And I believe that in the spirit of walk before run, it's important to understand what a good unit test is, how to recognize it, how to write it. And once teams are better at writing unit tests, then I think they can start moving in the direction of doing true TDD. And so, thank you, John. Moving on to the next one. I think first it's important to understand what unit testing is. So unit testing is, at its heart, really about making sure that you're verifying a very small piece of code, also known as a unit. And you want to make sure it's done quickly and you're doing it in an as isolated a manner as possible. All right, and the picture to the right, I think, is really key to understanding that. So at the bottom of that is one of the traditional shapes of Agile, the pyramid. The bottommost layer there is unit tests. And to fully understand why we have that depicted as an Agile testing pyramid, the emphasis really should be on writing super small, super fast unit tests and writing more of them than all the other tests really even combined. And we want to do this to emphasize how important unit tests are for providing super fast feedback on what the current state of our system is. Are we building the right thing and are we building it well? If we are writing true unit tests that are isolated, that are small, then they should be done the right way. So what is the relationship between unit testing and test-driven development? So test-driven development actually flips a lot of things on their head. You know, the traditional approach to testing where you build something and then test afterwards whether you got the right thing. It's obviously done in an opposite order in test-driven development. We want to have a developer heartbeat where you write a test first, and that test should fail. It should be a red test. And then you write just enough code to make it so that that test passes. And then you do some refactoring. And so the developer heartbeat is known as red-green refactor. What's really important in TDD is that you get that red test to verify that that piece of functionality doesn't actually exist in your system yet. And when you get the green test, then you know that you have fulfilled the contract of that test and you now have that piece of functionality in your system. It's important to emphasize here that TDD isn't simply a testing practice. It actually, as it says here, interweaves coding, testing, and design. And I also would want to emphasize that when I was mentored, I was told that TDD actually stood for test-driven design, because it was taught to me that TDD is at least as much a design practice as it is a testing practice. So writing unit tests is only one aspect of TDD. It's an important one, but you get a lot of other benefits when you're practicing true test-driven development. But as I said, very few people actually get to the point where they are doing true TDD. Rather, what happens is that most organizations say, okay, we want everyone to do TDD, but we have a hard time understanding how to measure that. I mean, how would you measure when it is that someone wrote that unit test? And what organizations usually land on is, well, one thing that we can do is measure how many unit tests are and what the code coverage is. So the prevailing metric in organizations is code coverage. It doesn't measure a lot of the things that you want to have as a benefit of TDD. It only measures really, it'll tell you how much of your code has been executed by unit tests, but really the major benefit that you get from your code coverage metric is a knowledge of how much of your code is not covered at all by unit tests. What it will not tell you is whether your unit tests are actually any good, whether the code that those tests are going against are any good, and whether they're actually effective. And so what we want to do is understand whether we are producing effective unit tests at all. By the way, the coverage metric can be easily gamed. We've seen it many, many times in with the teams that we coach, whether it's conscious or not. I mean, I don't want to throw developers under the bus, but if you are being told that you have to achieve, say, 80% code coverage, and you're not doing TDD, often what you're doing is you're backfilling a lot of your code coverage by writing unit tests well after the fact. And teams know that your code coverage metric is basically going to, it's basically going to tell you how many lines of code are executed by those unit tests. And so what you want to do is simply write tests that execute the code. They might not actually wind up doing anything real. There might not be any real assertions. They might actually be rather poor. What I want to emphasize here is that in many cases, there are teams that write kind of bad tests, and the bad tests over time take a lot of effort to maintain, more effort than maybe they're even worth, and teams have a hard time making any kind of progress on their products with bad tests. They're almost as bad as not having any tests at all. So what we would like to do is figure out what good tests are, what they are, how they are built, and make sure that teams understand just how to do that, so that they can make good and adequate progress while writing good tests. Okay, so what is the goal of unit testing? And the goal is, and that slide doesn't even seem to be appearing correctly. So there are a few things that we want to be able to do. One is you want your unit test to be able to protect you against regressions. If the external behavior of your, the observable behavior of your system changes in any way, you want your unit test to be able to alert you to this fact. You want also your unit tests to provide a good safety net for you, so that if you need to go and do some refactoring, meaning that you need to change the internal implementation of your code without affecting the observable behavior of your system, you should be able to do that, and your unit tests should all still pass. That's the very meaning of that safety net. And ultimately, you need good maintainable tests that are providing really good value to you, and that they are there so that your team can make good and adequate progress without the unit tests weighing them down, and actually to enable the unit tests to actually lift them up and move them forward so that they can continue to be productive. All right. So how do we do that? How do we achieve this? Well, I would advocate that the best way forward is to follow the mnemonic of first, which is the very next one. Thank you, John. So what we want to do is to make sure that our unit tests are fast, isolated, repeatable, self-validating, and timely. If your teams can follow that mnemonic, then I think that their unit tests will be really good. So what does it mean for unit tests to be fast? So we want each unit test to execute completely in just a few milliseconds. And in fact, you should be able to run thousands of unit tests in a matter of just a few minutes. And that should lead to super fast feedback cycles. All right. Thinking back to the pyramid in that TDD picture at the very beginning, or the unit testing picture, one thing that I want to make sure it's understood is that the unit tests are really supposed to execute at the smallest level of your code. Developers are writing your unit tests. Your unit tests are essentially aware of the implementation details in your code. Tests need to be fast. Developers are writing unit tests. Sometimes developers don't necessarily understand, if they aren't really knowledgeable about what true unit tests are, and they will try to write unit tests that cross architectural boundaries, that hit databases or some other microservice or some other website. If you have a unit test that is crossing an architectural boundary like that, then it isn't a true unit test. It might be something that is truly necessary to test, but it isn't a unit test. And we want developers to write those tests in that way so that they are super fast, and you can execute hundreds, thousands of them in a matter of minutes. Get that super fast feedback. Okay, so that's important. The next thing is to be isolated. And as I just mentioned, you shouldn't be crossing any architectural boundaries. Well, so what is the big benefit there? If you are not crossing architectural boundaries and you do have some dependencies from the part of your system that you're writing and you need to test, then you need to be able to isolate your part of the system from those other dependencies. You can use some really nice tools, some mocking test frameworks. In Java, it's Mockito. In .NET, it's RhinoMox. Those tools are wonderful for allowing you to isolate your part of the system from those dependencies. They can be a little tricky to use, so developers need to be taught, need to learn how to use them and to use them properly. Sometimes we see developers using mocking frameworks and they wind up doing nothing more than testing their mock. You should really understand that when you're writing your unit test, the mock isn't the thing that's being tested, it's just facilitating the test. You can also use mocks in a way that makes it difficult to do some refactoring. If you've mocked your dependencies in such a way that your unit test is very tightly coupled to your implementation, you might find that you have some unit tests that will fail when you try to do some refactoring. So you don't want that. But if you have exercised really good isolation, then it'll make it much, much easier to maintain all of your changes to your unit code. Everything is much more readable, and it's less likely that any changes to your tests or to your system are going to impact other tests. So there's many, many benefits to exercising some really good isolation. Okay, next. You want your tests to be repeatable. And what we mean by this is that you should be able to run all of your tests in any order, and you should get all of them to pass every single time. They should wind up with the same inputs and the same outputs every single time. Everything should be very reproducible. And you should be able to trust that if a test passes once, it'll pass consistently. So what you want to do is to make sure that all of your unit tests are super predictable, reliable, and that you have eliminated any kind of flakiness from them. We want ideally for our tests to be super reliable and trustworthy. If they are, then they're valuable. It's very difficult if you have any tests in your framework, in your suite, that are flaky. I would say that tests that occasionally fail are probably less valuable than tests that fail consistently. If it's consistent, at least you know what to do about it. If it's flaky and sometimes passes, sometimes fails, then you should really pay attention to that and make it so that all of your tests are repeatable. Sometimes it's often an indication if those tests are occasionally failing that you haven't done the proper isolation of those dependencies, and some dependencies are leaking in to produce some flaky results. So repeatability is super important. All right, now self-validation. What you want to do here is to make sure that your automated unit test can determine all by itself whether it has passed or failed and should not have any human intervention necessary for that kind of determination. Your test should be incredibly deterministic on that scale. So what you want to see is that all of your unit tests have really good assertions. The assertions that are in your unit tests are there to make it so that you can get immediate feedback on the correctness of the code being tested, and that your testing engine is ultimately going to tell you whether all of your tests are green, meaning everything passed, or red if even one failed. And that can only be done if you have some real assertions in your tests. I will say that sometimes I do see unit tests where either there are no assertions in the test, they're just executing code, or the assertions that are there are essentially meaningless. You might go and write some test code that exercises your code and gets you some coverage, and at the end of it, you have something that just says assert true equals true. Well, that's going to pass, right? And that's not really going to be self-validating. It's not going to be able to automatically tell you about the correctness of the code being tested. So make sure that your tests are self-validating. And then finally, perhaps most important of all, is the timeliness. How are we doing? Yeah. Okay. So timeliness. You want to make sure that your unit tests are written as close in time to your application as possible, your application code. What I mean by this is that you should not wait until a subsequent sprint, near the end of the sprint, or even at the end of the day. You should write them now while you're in the zone, while you know exactly what the code is, what the expected behavior is, and you can make a small change to get a test running that will validate that change is a good change. This will sound very much like what we advocate with test-driven development when you write the tests first. We know, having worked with a lot of teams, that a lot of times developers have a difficult time thinking about what that test is going to be before they write the code. Understanding that, though, we do want to encourage everyone to write it very, very soon after. If you're not going to write it first, write it immediately after you wrote that code, when you understand what it is that that code was supposed to do. And if developers start getting into the habit of writing that, then I don't think it's much of a leap to go from writing it immediately after you wrote a statement in your code to writing it just before. You'll almost be there. If you don't write it immediately after you wrote that statement, write it an hour or two afterwards. I mean, that sometime that day, really get around to it, make sure that that happens. And one of the greatest benefits of doing it that way, a huge byproduct, is when you write your tests in a timely manner, you're almost automatically going to get a very high level of code coverage. And even more so, the code coverage that you get is actually going to be reflective of probably a higher level of unit tests anyhow, a higher quality. You're going to have tests that are valuable. You're going to have tests that can protect you against regression and hopefully can help you do some refactoring, alerting you to whether a test might have failed if you do some refactoring. So remember this mnemonic, and remember that the timely part of it is, in my opinion, one of the most important aspects of this. Okay. I hope I haven't rushed through this too much, but here's our call to action. I want to emphasize that unit testing is an essential element of modern software development. Virtually every organization that does software development now, especially if they aspire to doing anything agile, is telling developers they must do unit testing. They are saying that unit testing not only must be done, but they want to have a very high level of code coverage, and they want it to be at 60 or 80%. That tends to be a norm. However, want to make sure that everyone understands that it's not just about writing a lot of unit tests. We want to make sure that everyone understands what the goal of effective unit testing is. We want to make sure that teams are using unit tests to enable them for sustainable growth. We aren't in the business of just writing unit tests. We're in the business of providing value to our customers and developing working software to production so that that value can be delivered to customers. If we tell people that they have to write unit tests, we want to make sure that they're not just sinking a lot of time and effort into writing something that is useless or even over time will bring them down. We want them to make sure that those unit tests over time will actually protect them against regressions and allow them to refactor their code with confidence. But a lot of teams do not really adopt TDD, not at the beginning and not even after a long time. In order to have unit tests that enable that sustainable growth, I believe that it's important for teams to focus on the first mnemonic: fast, isolated, repeatable, self-validating, and timely, so that they can learn what a good unit test is and implement those good unit testing principles. And after they have really gotten into the groove of adopting those first principles, then I think they can more successfully transition to doing test-driven development. And even if they don't quite get to pure test-driven development, those first principles will go a long way toward getting really good high-quality unit tests into their system and enable the teams and the products to go forward. All right.